Welcome all. In this lecture, we will be seeing the basics of the requirements engineering. Before getting into today's lecture, we will be just recovering our previous lectures. In our previous lecture, we saw what is software. Software is always a product or a path to a product. We also saw software should have instructions along with the documentation. Software defined or developed lifecycle should follow the important steps such as the process framework should encompass communication, planning, modeling, construction, deployment. Communication means requirements gathering and understanding the customer's needs. Planning means defining the resources along with the timelines and estimation of cost. Modeling comes under creating the structural designs, that is, UML designs and flowcharts in order to guide the architecture. Construction is writing the code and executing the unit test. Deployment means delivering the functional software to the users and it provides even the maintenance. So we saw this is the important steps of any conventional software which will be developed using a simple model. This is a sequential model. And here the important step is communication, that is requirements gathering. In this lecture, we will be covering how this requirement engineering is done. If you see requirements, it is of two types. One is functional and non-functional. That is what we are going to cover in this lecture. What is functional and non-functional requirements? Then the requirement engineering process, which has the following steps such as requirements elicitation, requirements specification, requirements validation, and finally even management. So this will be discussed in this lecture. First of all, if you see, the communication is the first step in any software development life cycle. If you see this slide, the first that is in the left hand side. This is what the customer has explained, how he wants a swing, right? But once after he has explained this to a project manager, but the project manager, what he understood is this one, But the customer has explained and his requirement is the first one, whereas the project manager understood in this way, that is how he wants a swing. Whereas this third clip shows how he has elicited, how he has explained to his engineer what the customer wants. This is how the engineer understood, right? And he has designed even in this way only. Whereas the fourth clip shows how this technician has built what an engineer has designed. Finally, this is what this fourth clip shows how the technician has built this way. But so pathetic. This last clip shows finally what the customer got in his hands. See, the first clip shows what he expects, whereas the last clip shows what he got at the final state. And this is what happens in our software project also. The customer expects something, but finally the product what he gets is something else. What happens in the middle? What is ruining it? Yes, it is communication. Communication is very important from the beginning till the end. How should the requirements be gathered? How should we gather the requirements? It is not just requirement gathering, it is requirements engineering. That is why it is called as requirements engineering. The process of establishing the services that a customer requires from a system and the constraints under which it operates is very important. The system requirements are the descriptions of the system services along with the constraints. See, it is not just only the descriptions. For every description, there will be a constraint also. That is why it is always called as functional and non-functional. What is a requirement? What is a requirement the customer is going to give? It is a high-level abstract statement of a detailed mathematical functions. It is a specification, what he wants. He gives specifications of what he expects. Those functional specifications are put forward. It can be a basis for a bid of contract. Therefore, it must be open for interpretation, or it can be basis for a contract itself. That is why it should be defined in detail. Or it can be the combination of both these. That is, should be interpretable. Also, it should be defined in detail. Nothing but what he wants. What is that he expects? Now let us see. If a company wants to let a contract for a very large software development project, right? Then the requirements must be written accordingly, like bidding a contract. And that is how the client's requirements have to be met. Once a contract is completely been awarded, we have to validate this is what the client expected and that is what he is having in his hand. That validation is very important. It has to be even documented. If you see, the requirements are of two types. One is user requirement, the other one is system requirement. User requirements are nothing but it is a statements in natural language, just natural, how we speak. Yes, I want this. Yes, I do not want this. This is what is expected, just in a natural language, along with some diagrams. That is user requirements. It is just written for the customers. What is then system requirements? System requirements are the detailed descriptions of the system's functions, services, and operational constraints. Right. The first one is written for the customers. The next one, it can be a contract between the client and the contractor. Yes. So the first part shows the user requirement, whereas the second part shows the system requirement. Now let's take a Menke system. Menke systems work is to see what are the reports in let's take it as a drug company, okay, or a pharmacy, something like that, a pharmaceutical company. So Mencare system should develop or generate the monthly management reports showing the cost of drugs prescribed by each clinic during that particular month. That is the user requirement. Whereas the system requirement on that particular day, what is the summary of the drug and what is in the report of that particular time, how much drug is given, the dosage of drug, the number of drug, the number of prescriptions, how to access the cost of the drug. All these are the system requirements. It is a detailed one. Whereas user, just the cost of drugs in a particular clinic. If you see user requirements, yes, it is client who is just getting it. It is between it is like a system and an end user, client managers, client engineers, contractor managers, system architects. System requirements are between system end users, client engineers, system architects, and software developers. Let us now see what is functional and non-functional requirements. Functional requirements are nothing but the statements of services the system should provide. That is, how the system should react to the input and how the system should behave in a particular situation. If this is an input, how it should react. And for this particular situation, how it should react. That is this functional requirement. It may state what the system should not even do. That is also being possible. And what is non-functional requirement? If this is an input, this can be an output, or this is the situation, this should be an output. That is functional. Then what is non-functional? The constraint towards each input or each situation. If this is an input, yes, The system will react in this way. Always, it also has a constraint for that particular input. The constraints on the services or functions offered by the system, such as this constraints can be timing constraint or development process standards or some other constraint. This constraint is not just for the system, but even for the complete domain of operations. Now let us take the same Mencare system. A user shall be able to search the appointment list for all the clinics, and it will be given to the system, and for each staff member using the system shall be uniquely identified by his employee number. It can be an 8-digit number. How the requirement should be. So requirements, if you see, what is the problem with the requirements is ambiguous requirements. Ambiguous requirements is we do not know who is the customer and what is the developer and what the developer has interpreted. All these are ambiguous one. That is why always the requirements should be complete and consistent. Complete in the sense all the facilities should be included. The description should be including all these things. Consistent in the sense there should not be any contradiction or confliction in the description of the requirements, right? The next one is the requirements. If you take non-functional requirements, right? I told you it is constraints. If these constraints are not met, then the system will not be useful at all. It will go useless. That is why non-functional requirements are more critical than the functional requirements, which will act as a constraint to each functional requirement. Let us now see what are the possible non-functional requirements. The possible non-functional requirements can be of 3 types. One is product requirements, the other one is organization requirements, the other one is external requirements. Under the product requirements, it is efficiency, dependability, security. Under organization, it is environmental, operation, and development. Under external, it is regulatory, ethical, and legislative. If you see, what are these requirements? Performance requirements, the space requirements, usability requirements, safety requirements, all these are non-functional requirements. So how to have this non-functional requirements? How this affects the overall architecture of the system? Because even if a single non-functional requirement is not working, this is going to completely harm the full, that is the complete system, right? So though it is a finished product, that will be harmed because there is a single non-functional requirement which has not been completed. This may generate, because let's take the non-functional requirement here is security. The security is not been achieved, right? If you're not concentrating on the security of this complete system, then this is going to be a great danger for the complete product. That is why non-functional requirements are very more important, and it is of classified under product, organizational, and external. Product in the sense requirements which is going to specify that particular delivered product, how it should be behaving in a particular way. Let's take speed, reliability. Organization requirements are like what is the standard that organization have to be following, all these. External requirements are the other one, that is interoperability and legislative requirements, all these. Let's take for Mencare product requirement in the sense working hours, within this hours. So within this hours, there shouldn't be any issue. If a downtime happens within this normal working hours, then there is an issue. Organization requirement, yes, security is an important thing. How you have to authenticate, like the identity card have to be checked. All these are organization requirements. External requirements are how many patients should be asked to come in and how they have to implement the plan. All these are external requirements. Now let us discuss what is a goal and a requirement. Goal is an intention of a user, whereas requirements is very important. It has to be precise. It should be usable. It should be usable and it should be testable. Usable, testable is very important. That is why always these comes under the non-functional requirement. The popular non-functional requirements are speed, size, ease of use, reliability, robustness, and portability. So these are important non-functional requirements under the requirement engineering. Now let us see what is SRS. SRS is Software Requirement Specification. You can also call that to be Software Requirement Document or SRD. Software Requirement Specification, that is SRS, have requirement specifications only. Why you have to specify the requirement? Because we have to specify the user as well the system requirements properly. It is very more important. You have to specify it properly. It should be written either in the natural language just by a sentences or a proper structured language, or you can even show it using UML designs or using a programming language, or graphically you can denote it, mathematically you can specify it anyway, but the requirements have to be specified properly. This is more important so that the system will not get damaged and the requirements and designs are not separable, right? So requirements are very important. Natural language is how we speak. It is just expressive and intuitive so that everybody can understand. It should not include any jargons in that. Also, you have to identify the important parts of the natural language. We have to be inconsistent. The inconsistent things have to be avoided. The consistent way have to be followed in that. And if you see, we have to practice the proper natural language. That is very important even in the pump software system, right? It has to be structured always. Structured in the sense too rigid one is not being important. It cannot be included for writing a business requirements. It should be a functional one and an entity because we have to describe what are the actions that has to be taken, and the description of the inputs and outputs are very important. If there are some side effects, even that has to be shown. Let's take a simple example of an insulin pump. We have to describe what is that being computed. Yes, if the insulin dose have to be delivered, how much dose has to be delivered, and what should be the input and what should be the output. Completely, it has to be described. And even the precondition, postcondition have to be given so that there will not be any side effects. It can be in a tabular specifications also, like this is how the tabular specification looks, the condition and its action. You can even use UML diagrams for that. This is a UML diagram example for the same Mentcare system. Diagrammatically, even we can showcase it, or even as a programming language base also we can showcase it. If you take an SRS document always is an official statement of what the system developer should implement. It includes both the user requirements for a system and a detailed specification of the system requirements. Yes, we have diverse set of users ranging from the senior management of the organization to a simple engineers. So for each user, the requirements will be specified. If you see the system customers, managers, system engineers, testing engineers, maintenance engineers, everyone should follow this SRS document. And the information in the requirements document completely depend on the type of system and the approach the development that has to be used. Mostly it should follow the required standards, right? And this is a small clip of using the standards. Now let us go to the requirement engineering process. Always the requirement engineering process should follow these activities. The first thing is requirement elicitation. The next step is requirements analysis. The next one is requirement validation. The next step is requirement management. What is requirement elicitation? If you see, the requirement engineering process follows these steps. However, it depends on the application domain and the people involved in the organization by developing the requirements. And this is an iterative activity even. Iterative activity in the sense, why this is an iterative activity? In the middle even, some requirements can be like the the engineers will be forced to incorporate even those requirements in the middle because the clients or the customers likes those things. So requirement engineering is a systematic and iterative process of identifying, analyzing and documenting and even managing the stakeholder needs for a system. If you take the elicitation, it is a process of gathering the information directly from the stakeholders through the interviews, workshops, surveys, and prototypes. The complete focus is on understanding the core problem, user requirements, expectations, and the domain constraints. Yes, the outputs are the user stories that we'll be discussing in the next lectures. Raw user stories, use cases, and notes. The next one is requirement analysis. Here, even the negotiation can be done. Reviewing and refining the gathered data to resolve the conflicts, clarify the ambiguities, and prioritizing the needs. The outputs will be the UML diagrams or the prioritized feature list along with the system models. Here, the focus will be completely on having a realistic, testable, and feasible time and budget constraint requirements. The next step is specifying the requirement. We have to specify it. The output will be an SRS document always. The third step is requirement validation. Here, if you see, both verification and validation will be involved. What is this verification and validation? Checking that the specified requirements accurately reflect the stakeholders' needs and are being technically correct even. Verification means it ensures the requirements are complete, consistent, and well written. Whereas validation means it ensures the system, when it is built, while it is actually solve the user problem. That is, we can validate what the customer expected and what he has in his hand at the end. Finally, it is management. Management is controlling and tracking the changes of the requirements throughout the entire project lifecycle. The outputs are the version control logs and the traceability matrices, which should maintain the traceability from the initial concept till the final scope. So these are the 4 steps that has to be followed in the requirement engineering process. In the next lecture, we can discuss on what is agility, why there is a need for agility, and why people have shifted from conventional process model to agile framework. What are the actions under agile framework? We shall discuss these things in the upcoming lectures. Thank you.